Hi Grade 9s. This video is going to be another video where we go through your winter assessment. Dr. Thornton and myself wanted to give you guys a video that's standardized so all of you get to see the same video, and also it's nice that you can have a video that in October when you're busy preparing for your November exam you've got a video that you can refer to when you use your winter assessment as for revision. Okay. Please, as with every exam, you need to read the instructions carefully. So we don't just give you instructions just for fun, you actually need to read them and follow them. So make sure you've got all the pages of your question paper and a data sheet. Okay, so this paper at 17 pages and you get a 2-page formula sheet. You're going to get the same one in November. Okay, write your name on every page. This is especially important because if a page drops out, we won't know whose it is. And for your winter exam, you guys did it online. So you had to scan it and send it to us. We then printed it. And if we print it and your name isn't on at least the front page, but preferably every page, we don't know whose it is. So it makes our life a lot harder to try and see identify the handful of people who never wrote their name on their work. So please make sure you do that. Also number every page. That way we can see if you've left out a page, or if when you scan it and it doesn't come through in the order that it's meant to, we can arrange your pages correctly. So please number every page as well. Leave a blank line open between every question and sub-question. So not just, for example, between question 2 and question 3, between question 2.1 and 2.2. You need to leave a blank line open. The reason why is if we need to write a little comment or an explanation to give you guys some feedback when we're marking your tests, we've got the space to do it. Also gives us space to put your marks in and to put the ticks and crosses when we're marking your work, and it's easier to add up if there's spaces between your work. We can also see where your one answer is ended and your next answer starts. It also helps you because if maybe you go back when you're reading through your work and you want to add in another sentence, you've at least got a blank line that you've got some space to do that if you need to. So that's the reason why you have to leave a blank line open between every question. Use the total marks as an indication of the amount of detail required. So please, for a 5-mark question, make sure you give us 5 marks of work. You can't give a 1-word answer and expect to get 5 marks. Write neatly and legibly and present your work neatly. By this, please lay out your work the way that we've shown you, especially for calculations. I'll talk more about that when we start doing calculations. Round off all answers to 2 decimal places. You will have noticed many of you had a -1 on your front cover of your page. We were going to take off just 1 mark in total, even though you may have had many questions that you didn't round off to 2 decimal places. We didn't actually subtract that mark, but in November, every time there's a question that you don't round off your answer to 2 decimal places, you will lose 1 mark. In November, every time there is a question for which the answer you provide isn't rounded off to 2 decimal places, you will lose 1 mark. So please make sure you follow this instruction. Very important, 2 decimal places for every answer. Use the correct scientific notation, especially if we ask for it. If you give your answer in scientific notation, then make sure it's rounded off to 2 decimal places. Please revise that section on scientific notation if you're a little bit unsure. Make sure you always provide the correct SI unit. Many of you lost out on a mark. You know this already, even from last year. You lost out on a mark if you didn't give the right unit for each calculation. Very important to do that. Some of you did give a unit, but it was the wrong one. So please make sure you learn your SI units so that you know, for example, that if we ask you to calculate current, formula for current is I, you must give your answer with units of amps, ampere. Capital A is the symbol. You have to do that. All right, so multiple choice. Let's go through this. Which device is designed to convert chemical energy into kinetic energy? So this comes from your Forcework Energy Power booklet. There was a little question in there. This is very similar, where you had symbols. For example, there was like a picture of a sun to represent light energy. There may have been a picture of a stove and oven to represent heat energy. This comes from there. Okay, so April O'Neill's car petrol engine. So petrol, guys, is a chemical. There's chemical energy stored in the petrol. So the petrol is a chemical. And what's the point of having a petrol engine in a car? Well, to make the car go. When the car's going, moving, that moving energy is kinetic energy. So A is the right answer because you've got chemical energy being converted into moving or kinetic energy. Whenever you see kinetic, you must think moving. Okay. Leonardo's battery-powered torch. Let's just go through the wrong ones too, to show you why they were wrong. Battery powered, so yes, there's chemicals in the battery, sure, in your little Duracell cell there is chemicals, I agree, but the point of the torch is to emit light, not kinetic energy, light energy. So that one's wrong. A is right. Master splinters wind up mechanical clock, so that would be mechanical energy when you're winding up the clock will be stored as elastic energy and converted back into kinetic energy to make the clock tick. Wrong. Shredder's electrical oven, that would be electrical energy being converted into heat or thermal energy, so that's wrong. So that was what I was asking you there, the energy conversions. When a positively charged object is brought near, so near, we even put that word in bold, guys. When a positively charged object is brought near a neutral object, you should be thinking of induction, charge being transferred by induction. Then also we've got a whole bunch of answers about protons moving and electrons moving. Remember, protons do not move. Protons do not move. It's the electrons that move. And there's a question later in the test, in this exam, that asks why it's the electrons that move. So please, if you don't already know this, make sure you get that into your head. Only electrons move because they're small, they're light, and they're on the outside of an atom. So wherever you've got an answer where you've got protons moving, that's not going to be an option. Electrons of the neutral object moving, maybe. We'll read in more detail now. Are there any others where protons move? No. So the other B, C, and D are still options at this stage. Electrons of the neutral object move away from the positively charged object due to induction. Induction, and conduction. So because of answer D having conduction, that is wrong. Remember, I told you when you've got an object being brought near another one, you're going to have induction. Okay, so in this case, the electrons of the neutral object will move towards the positively charged object. So electrons of the one will move towards the protons of the other object due to induction. So D is not an option, C is right. Over here, for answer B, the electrons of the neutral object move away from the positively charged object. No. If you had two positively charged objects, then you would get repulsion. Or if you had two negatively charged objects, rather, then you could have electrons moving away from each other. Okay, so electrons are negatively charged, protons are positively charged. Negatively charged, positively charged. The electrons would move towards the protons, not away. So answer B is wrong as well. So that was testing a few things there, whether you knew about induction, how charge was transferred, versus conduction and friction. It was also testing whether you knew that protons remain in one place and it's the electrons that move. And it also tested whether you knew that opposite charges attract and like charges repel. So a few things being tested in that question. This question, if you got wrong, that is proof that you did not do the past papers that you were asked to do. This question was from the Saheti July 2019 exam. Exactly the same question. I may have rearranged these so that if you saw the question and you remembered, for example, it was the bottom right diagram, it won't still be answer D, for example, but the diagrams are exactly the same and the question is exactly the same. All I may have changed is the names. So, for example, turtles and Master Splinter wouldn't have been in there, it would have been other characters from that exam. But the question and what it's asking is exactly the same. How should you set up a circuit if you want to find resistance? So you don't get an instrument called a resistance meter. If you want to find resistance, you need to have an ammeter and a voltmeter. Voltmeters are connected in parallel and ammeters are connected in series. Please, you need to know that. So over here we've got a voltmeter that's connected in series and an ammeter in parallel, so that's not an option. Over here you've got an ammeter connected in series, so that's right, but the voltmeter, well, both of them actually, sorry, no, both of them are connected in parallel across that resistor. So even though the voltmeter is fine, that ammeter should not be there. Ammeter must be connected in series, and ammeter should be there, for example. So option C, not an option. Option D, here the ammeter is in series, so that's great, but the voltmeter is also in series, which is wrong. I said voltmeters must be in parallel. And this one, ammeter is connected in series correctly, voltmeter is connected in parallel correctly. Answer B is the right answer for that one. And again, if you didn't go through the past exam papers, this is why we tell you to do it. There will be one or two questions in your November exam that are from other past papers, maybe 2015, 2016, 2017, 2018. even last year, 2019. So you have to go through past exam papers. 1.4. Here we've got a balloon tied to a mass balance. There's a metal block on the mass balance. The metal block's got a mass of 100 grams, and the reading on the mass balance is 91 grams. The reason why the reading on the mass balance is a little bit less, the reason why it's 91 grams, not 100 grams, is because you've got the helium balloon. Remember, helium's lighter than air, so it will be exerting an upward force on the mass balance. So if you were to draw the forces acting on the mass balance, you've got the downward force of the metal block, you've got the upward force of the balloon, which I'm going to draw with a shorter arrow because it is a smaller force. And so this would be, well, you've got the mass of 100 grams and you've got the upward force of the balloon. So you need to convert these into weights using Fg equals mg. Okay. This is also not in SI units. Grams is not an SI unit. So if you do that, let's go Fg equal to mg. So the mass of the 100 gram block would be 100 divided by 1,000 to convert into SI units of kilograms. So that's your mass. Gravity on Earth is 9.8. That will give you a weight of 0.98 newtons. Actually, sorry guys, my apologies, you didn't need to do this. This electronic mass balance is giving us that. Okay, so we need to decide which of these options are correct. So the helium has a mass of 9 grams. No guys, the helium doesn't have a mass of 9 grams. Just because it's exerting an upward force doesn't mean that force, if you convert it into a mass, is 9. That's not true. Let's have a look at part 2. The weight of the metal block is 0.98 newtons. That is correct. Actually, you did have to do what I showed you over here. That's how you do it. So that part is correct. The weight of the metal block is 0.98 newtons. So take the 100 grams, divide by 1,000 to convert grams into kilograms, which is the SI unit for mass. And gravity on Earth, acceleration due to gravity, is 9.8 meters per second squared. So question 2 is, or part 2, Roman numeral 2 is true. So you need to have that as one of your answers. That allows you to eliminate option D. I also told you that the helium has a mass of 9 grams, also not true. We don't know. You can calculate what it is, but let's have a look at that part 3 and 4. The balloon exerts a downward force of 0.09 newtons on the balance pan. The balloon is not exerting a downward force. The balloon is exerting an upward force. Think of which way the force of the balloon would be going. The balloon would be going upwards. So that word makes that statement be wrong. So that's wrong over there. So option B is definitely not an option. And then part 4, the resultant downward force on the pan is 0.98 newtons. Is that true? Yes. If you convert 91 grams using this formula, Fg equals to mg, so you've got 91 grams, convert grams to kilograms by dividing by 1,000. Is it 91? Yeah, 91 divided by 1,000. Divided by 1,000, 0,091. Multiply that by gravity, 9.8. And you will get 0.89 newtons. So that is true. So you need an answer that's got Roman numeral 2 and Roman numeral 4. So II and IV. The correct answer then is going to be option C. So that one was a little bit of work, but not all the multiple choice questions are that long. And your matric paper will be exactly the same. Some will be very quick, testing a quick concept. Others will be longer, and that's how you needed to go through that one. Over here, good idea to draw a free body diagram of the forces acting on April O'Neil's car. So we've got air resistance acting to the left. So there's a free body diagram. The dot represents the car. Remember, arrows always go out of the diagram, not into it. So this force here, 800 newtons, is acting to the left. We've also got 500 newtons of friction acting to the left. You can draw it together like that. The 500 newton is a little bit shorter because 500 is smaller than 800 newtons. And you've got 2000 newtons, that's the driving force from the engine. I've drawn it as a very long arrow because 2000 is a lot longer than 500 or 800. What is the net force that's acting on the car? Well, got 2000 to the right and 500 and 800 acting to the left. So 2000 minus 500 minus 800 means that the resultant force is 700 newtons acting to the right. If you've got a resultant force, then it means that the object is going to be speeding up from Newton's laws. Okay. If you've got an object that's speeding up, is that one of the options over here? Yes, option C. The car is not going to be moving backwards if you've got a resultant force acting to the right. So A is a lie. The car is slowing down, that's a lie. The car is moving at constant speed. If there was no resultant force, so let's say that the driving force of the engine was 1,300 newtons. Then you've got 1,300 to the right and 500 plus 800 acting to the left. So you've got the same amount acting to the left and to the right. 1,300 to the left, 1,300 to the right. And so they cancel each other out. So then F net is 0. 0 newtons. That would be the car moving at a constant speed or stationary. Okay. But you did have a net force. The net force was 700 newtons to the right. That's why the car was speeding up. All right, now we've got a question that asks which diagram represents a mixture of two compounds. So a compound is two or more chemical elements, different elements that are chemically bonded together. So you could have X and Y and element P and Q chemically bonded. They are different. And the mixture means that you've got element compound XY and compound PQ, both of those in a container, but they're not chemically bonded together. So let's go through this. Let's start with the easiest. Option C, you've only got one type of element here, and it's not even a compound because you've just got the same atom. They're not even bonded. So option C is just a pure element. Okay, let's look at option B. Option B, you've got open circle, closed circle, open circle. In all three of these, that one, and that one are all exactly the same. So that's just one compound. So option B was just one compound. That's not right because we need a mixture of two compounds. Let's have a look at option D. Option D, that's an element, that's an element, that's a compound, that's a compound. So option D is a mixture of one element, the circle, and the compound, what I've done in a rectangle. So that's an element, a mixture of an element and a compound. So option D is not right, which means that option A must be true. Let's check. You've got closed circle, open circle, closed circle. Closed circle, open circle, closed circle. So those two are the same compounds. They're a compound because the open and closed circles are chemically bonded together. Then you've also got open circle, closed circle, open, closed, open. Those two are the same. And so that is a different type of compound because you've got different amounts of elements bonded together. So option A is correct. So I was testing whether you knew the difference between elements, compounds, and mixtures. This, guys, was directly from your balancing equations revision worksheet. I forget exactly what number, but if you go and have a look on your balancing equations revision worksheet, you will find that exact equation. And you were asked to balance it. For 1.7, the correct answer is B. If you still struggle with balancing equations, you need to go and rewatch the lesson that we did last term on balancing equations. You may need to watch it twice if you're still struggling a little bit. Tests whether you also know how to apply subscripts as well. Okay, so that was something that you should have seen before. If you did it in the revision worksheet which you were asked to do, then you should have been able to do it quite easily in this exam. Now, naming compounds. Which row contains the correct U-pack It means International Union for Pure and Applied Chemistry, names for the following compounds. So H2O2, that is not water, guys. The formula for water is H2O. This is methane, CH4 is methane, and NH3 is ammonia. But these are not necessarily UPAC names. For example, water is not a UPAC name, it's actually a common name. Okay, so let's go through this. So this is why water is a common name. Ammonia is also not a UPAC name, it's a common name. Okay, same with methane. So hydrogen oxide, that the formula for this compound would be HO or OH. And you've got H2O2, so that's not right. Okay, hydrogen dioxide, that would be water. No, sorry, no, it wouldn't. That would be HO2, 2 oxygens. That's not what you've got. Dihydrogen, remember di means 2, di means 2, so you've got dihydrogen, so 2 hydrogens, dioxide, 2 oxygens, so H2O2, and that is what you were given. So for the H2O2, option D is right, but you need to check the others too. Carbon tetrahydride, tetra means 4, so you've got 1 carbon and 4 hydrogens. That's what you were given, so that is right. Nitrogen trihydride, 1 nitrogen, tri means 3 hydrogens, so NH3, that's what you were given. So option D is correct for this. Okay, a little bit of recap for you. You get ionic compounds, which is a metal and a non-metal. When you've got that, you don't use prefixes. None of these were ionic. They were all a non-metal bonded to a non-metal. So hydrogen, oxygen, carbon, hydrogen, nitrogen, hydrogen, those are all non-metals. So those are covalent compounds when you've got a non-metal bonded to a non-metal. So you do need to use prefixes. For example, CO2 would be carbon dioxide, di meaning 2. Okay, now, this tests whether you know how to use the periodic table. On your periodic table, every element has got at least 2 numbers. There might be a small number with a decimal in the top right, that's electronegativity. You don't need to worry about electronegativity until next year. For this year though, you just use the mass number and the atomic number. So mass number is the protons and neutrons added together. The mass of your protons, each proton has a mass of 1, each neutron has a mass of 1. Mass number is those two added together. Atomic number is just your protons only. So the bigger number is obviously the mass number because it's both of them added together. So you need to go to your periodic table and see how many protons cobalt should have, how many protons calcium should have, iron should have, carbon should have. And once you've done that, you didn't even need to look at the neutrons because that would give you enough information to answer that question. If though we gave you 2 of the same element, sorry, I've lost my page. If we gave you 2 cobalts with both of them 32, you'd then have to do a bit of maths to work out, take the mass number minus the proton number to work out how many neutrons it's got. So that is what you should have done. The correct answer for this one was C, iron with 26. If you have a look on the periodic table and you find iron, you'll see iron is got 26 and 56. Okay, cobalt is 27 and 59. 27 is its atomic number, 59 is its mass number. So cobalt should actually have 27 protons. So that's wrong. Calcium should have 20 and 40. So that's wrong, that should be 20. Carbon should have 6 and 12. So carbon is wrong. Okay. Iron 26 and 56. If I asked you how many neutrons it's got, you'd go 56. That 56 minus 26. So the total mass number, which is protons and neutrons added together, if you remove the protons, then you'll be left just with the neutrons. So for this, 56 minus 26 will give you 30 neutrons. That's how that works. So option C is the correct answer. And then the last multiple choice question. Which of the following elements, remember elements, not compounds. Okay, so if you've got compounds here, then you can ignore it. Are non-metals, remember, non-metal is to the right of your step line on the periodic table. So you need to know where that dividing line is. Starts off to the left of boron, goes above aluminium, and then down to the right of aluminium, and so on. You need to know where the metals and the non-metals are. So to the right is the non-metals, to the left of the step line is your metals. Exist in the liquid phase at room temperature and pressure. So the only elements that exist as a liquid at room temperature and pressure are mercury, Hg, and bromine. Now, mercury and bromine, guys, those are elements, so that's fine. If there was a compound there, you ignore it. And there is. Water is a compound. And yes, water is a liquid at room temperature and pressure, sure, but water is a compound, not an element. And they are specifically for elements. So anything that contains option 3 is a lie, so you can cross out D. I said mercury and bromine are liquids at room temperature. However, mercury is a metal. They specifically asked for non-metal, so mercury is not an option. So bromine, option B, is the right answer. All right. Question 2, that was about electrostatics. In electrostatics, the electrostatic force between two charged objects is related, we don't know how yet, to the distance of separation between the two objects. Actually, you do know how from the experiments that you did in class before lockdown began. Increasing the separation distance, so meaning a bigger distance between the two objects, changes the electrostatic force between the objects. So you've got definition and a law. I'm not going to read those to you because those are straight from your notes. During coronavirus, and so many of you lost marks for definitions. Some of you made up your own wacky definitions. Guys, in matric, you have to know the IB's definitions. You can't go Google them, even though they might be similar. The IB wants the definitions that they give you. We want the definitions that we give you. So please don't Google it and make up your own. You have to give the exact definition that's in your notes. Good idea to get some cue cards. And on the one side, you would write down, for example, electrostatics. And the other side, you would write electrostatics is the study of stationary electric charges. And that'll help you to test yourself. And you're going to be getting definitions right up until matric. It's a good idea to start learning your definitions now. During the coronavirus lockdown, Donatello was able to have his hair cut. Shame. Oh, he wasn't unable. He was unable to have his hair cut. Shame. Donatello actually has fluffy purple hair. Who knew? One day, Donatello rubs a rubber balloon against his fluffy hair as shown in the image below. So there's the balloon, and he rubs the balloon forwards and backwards against the hair. Charge can be transferred in 3 ways. You should know those as you're reading the question. You should be thinking of the ways that charge can be transferred. Induction, conduction, and friction. Explain how friction between the rubber balloon and Donatello's hair caused his hair to become charged. So you needed to explain that when the balloon was rubbed against his hair, electrons were transferred. Remember, it's not the protons. I've spoken to you about that already in the multiple choice question. So when the balloon's rubbed against Donatello's hair, electrons were transferred. From where to where? So from his hair to the balloon. You were given a triboelectric series if you needed to work that out. So there's the balloon, there's the hair. The hair would lose electrons. If it loses electrons, it would become positive, and whatever is negative would need to gain electrons to become negative. So hair would lose electrons to become positive. That's why hair is higher up on the triboelectric series. Here's rubber. Rubber is lower down, so it would gain electrons and become negative. If it's gaining electrons, electrons would have to go from the hair to the rubber. Okay, so to get your first mark for that question, you would need to say when the balloon was rubbed against Donatello's hair, electrons were transferred from his hair to the balloon. And you could have also said electron transfer due to friction caused an imbalance of charge, meaning one object was more charged than the other. Electron transfer due to friction caused an imbalance of charge. Alright, 2.4.1, does a triboelectric series rank materials based on the material's affinity for protons or the material's affinity for electrons? Guys, it's electrons. Triboelectric series ranks materials based on their affinity to lose or gain electrons, and the reason why, by referring to atomic structure, is because if you have a look at the structure of an atom, in the center of the atom you've got the nucleus. That's the nucleus that I've circled in green. Inside the nucleus are the protons and the neutrons. They are heavy. and now inside the center of the atom. Whereas the electrons, which are done in blue around the outside of the atom, they're small, they're light, and they're around the outside of the atom. So for those three reasons, because they're small, light, and around the outside of the atom, they're easier to remove, and that's why it's electrons that are transferred. Okay. So materials are ranked based on their affinity for electrons because electrons are small, lighter than protons, and they're found around the outside of the atom. Therefore, they're more easily removed or added than protons. Good idea if you're battling a little bit with this to see the triboroelectric series questions that are in your electrostatics notes and the past papers and the tutorials that we gave you. These are very similar questions all the time. What material would you suggest he should rub against his hair in order to get the opposite charge to that created by the balloon? So here's hair in the green box, and there's rubber. So that would mean that the hair would become positive if you rub it against rubber, because the electrons would be lost by the hair and transferred to the rubber. If you wanted to gain the opposite charge, then you need to rub it with something that's on the opposite position to the rubber on the triboroelectric series, something higher up. There is only one object that's higher up, one substance that's higher up on the triboroelectric series, and that's the human hand. So now, instead of the human hair becoming positive, the hand would become positive and the human hair would become negative because now the hair is lower down. Remember, the rubber here became negative because it was lower down on the triboroelectric series. We'll go through that one more time quickly. When you've got hair and rubber being rubbed together, the hair is higher up on the table, so hair would become positive because it's higher up on the table, and rubber negative because it's lower down on the triboroelectric series. However, if you rub hair and a human hand together, now the hand is higher up and the hair is lower down, so now the hair would become negative and the hand positive. So you needed to rub it against a human hand or a turtle hand, because we did tell you that turtle hands have the same properties as human hands. Okay, question 2.4.3, why is there an electrostatic attraction between the balloon and the hair? Well, the balloon gained electrons from the hair. I did show you that. So the balloon gained electrons from the hair, and therefore if the balloon gained electrons, it would become negatively charged. If the balloon gained electrons from the hair, then that means that the hair must have lost electrons to the balloon. The hair lost electrons to the balloon, and if the hair lost electrons, if you lose electrons, it's going to become positively charged. So the balloon was negative, the hair was positive, and according to the law of electrostatics, opposite charges attract. So if you've got the positive hair and the negative balloon, they're oppositely charged, and opposite charges attract according to the law of electrostatics. 2.4.4. Explain whether the electrostatic force can or cannot be regarded as a contact force. Contact, remember, means touching. Okay, so can it be regarded as a touching force? No. An electrostatic force cannot be regarded as a contact force because an electrostatic force can act over a distance. Think of when you guys were in class and you rubbed the balloon against each other's hair, or your own hair even. Okay, so there we go, green balloon, blue person. When you rub the balloon against the hair, if you bring the balloon near to the hair, even though it's not touching the hair, which I'll do in red, we can have a red head, the hair would be attracted to the balloon, even though the balloon might not necessarily be touching the hair. So let's move the balloon away a little bit. Okay, so we've got the hair. Even though the balloon's not touching the hair is still being attracted to the balloon. Okay, so it's not touching. If you look there, the hair's not touching the balloon, it's just close. But as you bring the balloon near to the hair starts being attracted to the balloon. So because it can act over a distance, it doesn't have to touch. If it acts over a distance, then it's a non-contact force. Just like gravity, if you jump up, the earth doesn't have to grab onto your legs and pull you back down. The force of gravity acts over a distance. Same applies with magnetism. Magnets can act over a distance. They don't have to touch each other for them to experience that force, magnetic force. They can act over a distance. So those are all non-contact forces. So you needed to say no. An electric force cannot be regarded as a contact force. An electrostatic force can act over a distance. 2.4.5. Which of the graphs above correctly show the relationship between electrostatic force and distance? So, first of all, have you ever seen any of these? You should have seen this one, and you should have seen a graph that looks like this when we're discussing the relationship between two quantities. So you should have seen E and you should have seen C before. In science, you haven't ever seen a graph like this yet, or like that yet, or like that yet. The other two maybe, but not E and C represent the types of proportion that you should be familiar with. Now let's think. When the balloon, let me cut this balloon and I can move it around to talk to you guys about it. Okay, so we've got the balloon. When the balloon is far away from the hair, then the hair doesn't experience as much of a force as when the balloon is closer to the hair. So as the balloon comes closer and closer and closer to the hair, the force, the electrostatic force between the balloon and the hair becomes greater. It increases with a smaller distance. When I move the balloon away from the hair, the distance between the balloon and the hair increases and the force decreases. The force becomes weaker when the balloon is further away. So think of the balloon, a rubber balloon on your hair. As you move the balloon further away, your hair doesn't stand on end, doesn't stand up as much. When you bring the balloon closer and closer to your hair, then your hair starts to stand up more and more. So which graph shows this? Well, graph E. So as your distance increases, so as you go to the right on this graph, you can even put in random values for you if it makes you happy. That can be a distance of 10. If we're going up in centimeters, remember the SI unit for distance is not the centimeter, it's the meter. If I made it centimeters, 10, 20, 30, 40, and 50. And electrostatic force, guys, is measured in newtons. Okay, so let's put on this force as well. You can go up in units of 10 as well, 10, 20, 30, 40. So at a distance of 50 centimeters, let's pick. Okay, so at 50 centimeters, we've got 5 newtons, for example, of electrostatic force. If I go to 30 centimeters, I've now got 10 newtons of electrostatic force. So the distance has gone from 50 to 30, so my distance decreased. So as distance decreases, force went from 5 up to 10, so electrostatic force increases. If I brought the balloon really close, now only 10 centimeters away from the hair, I'm now at about 50 newtons. Okay, so these are just arbitrary values that I made up just to explain to you that as distance increases, so as I go to the right on this graph, as distance increases, force becomes less. Or the other way around, I can say as I go to the left on this graph, I'm going up. So watch what happens as I trace my finger along here. As I go to the left, electrostatic force becomes bigger and bigger. Or as you go to the right, so as your distance increases, electrostatic force becomes less and less. As you move the balloon further away from your hair, electrostatic force becomes less and less. So option E was the correct one here, and you needed to explain that as separation distance between the objects increases, so as the balloon moves further away from the hair, the electrostatic force between the objects decreases. You could have said the opposite as well. As separation distance decreases, electrostatic force increases. Okay, name the type of relationship. So this, guys, is an inverse proportion. Just by the way, if I asked you for this one, that would be direct. For question E, this would be direct proportion. And this is inverse. Good idea to go back to your SI units notes from term 1 and have a look at that if you're still unsure. You decide to do an experiment to see if the amount of electrostatic force changes as the distance, so we're looking at force versus distance, between the balloon and Donatello's hair changes. So you could have done one of a few different experiments. You could have used the electroscope. Remember, the electroscope had the disc and the gold leaf. And as you bring the balloon, there's a balloon. As you bring the balloon closer to the metal cap, you could observe what happens to the gold leaf. Does the gold leaf go up or down? So that's the one way that you could do it. Another way that you could do it is you could use hair. So same as what I had over here. You could then measure the amount that the hair stands up or how many hairs lift up The angle of the hairs, you could do it using the hair in the balloon. You could do it that way. How else? Oh, when you had the plastic rods on the pivot, on the needle. So say, for example, you could explain this experiment where you had the plastic rod balancing on the needle, and you bring the balloon. So let's use the same balloon. It's okay, I'll draw another balloon. There we go, you've got the balloon. If you bring the balloon nearer or further away from the plastic rod, you could observe the movement of that plastic rod. So any of those experiments you could describe. So you'd have to get marks for saying the pivot or electroscope, and what other materials would you use. If you were using the electroscope, you'd have to have the electroscope and the balloon. You'd also maybe need a protractor so that you could put the protractor there and measure the angle that the gold leaf stands up by. So you could have a protractor there. You'd need a ruler to measure how much the hair lifts up by over here, for example. If it was like that and you move the balloon up, how much the hair changes by. You could measure the distance that you'd also need a ruler to measure the distance between the hair and the electroscope, the balloon and the electroscope, or the balloon and the plastic rod, and the balloon and your hair. You'd need a ruler. So you need to have a measuring device, and the pivot electroscope, fabric to rub against the rod to charge it. Those are the sort of things that you need to discuss. And then any 3 reasonable bullet points to describe the method of charging the objects by friction, and then measuring the force of attraction or repulsion. So those are the 3, any of those 3 experiments you could have described. So quite an open-ended question there. Method should have been in third person. So you don't say, I would do this and then I would do that. I would bring the balloon, I would rub the balloon against my hair. You say the balloon would be rubbed against human hair. No I or me in your method, please. And past tense, the balloon was rubbed, not rub the balloon against the hair. You do it like you did it yesterday, past tense, because that's how we do things in science. Okay, question 3. So this was an electricity question about the pizza oven. Define potential difference. Again, go find that definition in your notes. Calculate the potential difference of the pizza oven. By the way, this same definition, guys, was inadvertently tested in your controlled task from term 2. Calculate the potential difference. So we need to calculate V when it operates in accordance with the specifications provided above. So here, in order to calculate V, you should know the formula. So V is equal to I times R. V is measured in volts. I is the current. How much current passes through this device? There we go. Current 5.75 amps. Is it milliamps or picoamps or anything weird? No. It's already in amps, so you don't need to convert. So 5.75 amps times the resistance. What is the resistance of this device? 40,000 milliohms. Milli means times 10 to the power of minus 3. So there's 40,000, you'd have to go 40 times 10, 40,000 times 10 to the minus 3, because that's what milli means. Ohms. And that is actually just equal to 40 ohms. Okay. So you've got your formula, you get a mark for your formula. Then your substitution step, you also get a mark for converting. You can do it in your calculation if you want to, or you can show it separately on the side. That's fine, but you have to show it. And 40,000 milliohms, or 40 ohms, times the current of 5.75 amps will give you 230 volts. 2 decimal places, please. If you wanted to write it in scientific notation, 2.30 times 10 to the 2 volts. Note the 2 decimal places. Okay, so that's your potential difference. V is equal to 2.30 times 10 to the 2 volts, or 230.00 volts. 4 marks, done. If it takes 5 minutes, when you're reading this question, the 5 minutes should be flashing at you. It's not an SI unit. You need to convert minutes into seconds. by timesing by 60. If it takes 5 minutes to cook one pizza, how much work, so they're asking us to calculate work, remember work's measured in joules, is done by the pizza oven to cook a pizza. Write your answer in scientific notation. So the formulas that you've got W is equal to VQ. We need to calculate V and Q in order to find W. We've got V, that was what you that was the value that you used, that you calculated in your previous question. There we go. So V is 230 volts. So we've got V. W is what you're trying to calculate. V we've got, and now we don't have Q. How do you calculate Q? Q is equal to I times T. I, current, is 5.75 amps. Comes from there. How long does it take to cook the pizza? Well, 5 minutes. 5 times 60 will give you 300 seconds. So you need to show that conversion. Again, you can do it on the side or show it in your calculation. So 5 times 60. So you're going to have 5.75 amps times 300 seconds. And that will give you a charge of 1725 coulombs. 2 decimal places, 0.00, or 1.73 times 10 to the, you can write it in scientific notation if you want to. So it would be 1.73 times 10 to the 1.73 times 10 to the power of 3 coulombs if you want to. You have to have coulombs as your unit, otherwise you won't get your mark. Just like for potential difference, you have to have V, volts, as your unit, otherwise you don't get the marks. Okay. Once you've calculated charge, then you can take that answer, you can take this value here for Q, and you sub it into there. So W is equal to V. The V was from your previous question, 230 volts. So 230 volts times the charge that you've just calculated, which is 1725. I'm just going to put a line to show which I haven't laid out in our work very nicely, because I am squashing it in, but this should take up each line on a page. Okay. That'll then give you a total amount of work done of 396,750,00. The units for work are the joule. Okay. And that was 8 marks. A mark for each of your formulas. A mark for converting this 5 minutes into 300 seconds. Mark for your substitution, mark for your answer with a unit, mark for your substitution, and a mark for the total work done, 2 decimal places with units. 8 marks done. If 1.73 coulombs of charge, so that's your Q, 1.73 coulombs of charge pass through the pizza oven in 5 minutes, remember, convert to seconds. How many electrons pass through the pizza in that time? It's a very similar question in your notes. So we've got a Q of 1.73 coulombs. Q is equal to the number of electrons divided by the number of electrons in 1 coulomb of charge. The formula you're not given, but you are given the number of electrons in 1 coulomb of charge. Charge is 1.73 coulombs. Number of electrons is what we're trying to solve. And the number of electrons in 1 coulomb of charge is 6.25 times 10 to the 18. Straight from your data sheet. Okay, rearrange and you get the number of electrons. So you're going to basically multiply those two by each other. So 1.73 times by 6.25 times 10 to the 18 put it in brackets so that your calculator doesn't mess up the bot mass. And that will give you number of electrons 1.08 times 10 to the power of 19, and your answer is electrons. Okay, 3.5. So now we've got a pizza oven. It tells us that there's an indicator light bulb and a heating element. The light bulb is obviously exactly that, it's a light bulb, and the heating element is a resistor, which causes the pizza oven to get hot. After 6 months, the bulb blows, but Michelangelo notices that even though the bulb is blown, the pizza oven continues to work when it's switched on. So I ask you to draw an electric circuit diagram. Remember, when I ask you to do this, you need to use a pencil and a ruler when you're drawing circuit diagrams to show how the indicator light bulb, so the light bulb, and the heating element, the resistor, are connected. Use a battery. Battery, remember, 2 or more cells connected together as the power source. Include a closed switch which controls both the bulb and the resistor. So I'm not using a ruler or a pencil. Actually, I'm using an Apple Pencil. So let's have our 2 cells. 1 cell, 2 cells. Remember, this is the positive terminal, that's the negative, positive, negative. You don't need to show that though. It's the whole point of using symbols. Again, please pencil and ruler. Okay, so there's our two cells. If you just drew 1 cell, then it's not a battery. You were asked to draw a battery. A battery is 2 or more cells. Then you need to have a bulb and a resistor connected in parallel, so that even if one component blows, meaning even if the light bulb blows, the resistor will continue to work because current can still get to the resistor. You also need to have a switch. However, it says that the switch must control both the indicator light bulb and the resistor. So if you put your switch over here, for example, it would only control the bulb, not the resistor. So you need to have the switch in a position that controls both, so your switch had to be in series. And there we go. So now, even if this bulb is blown, so basically if it's removed from the circuit, current can still go from the cell. Conventional current goes from positive to negative. So from the cell through the closed switch to the resistor and back to the negative terminal of the cell. So you've got one complete closed loop, even though the light bulb was removed. So what you had to do was that. If the total effective resistance of the circuit due to the indicator bulb and the heating element is 40,000 milliohms, what would the total effective resistance do? Would it increase, decrease, or stay the same when the bulb blows? So in this bulb over here, when that bulb blows, it's basically removed from the circuit. There we go, bulb's removed from the circuit. So now there were 2 paths for current to take. So more current could go through, so that must have meant that there was less resistance. Now there's only 1 path for current to take once the bulb is blown. Oops. So there's a bulb, bye-bye bulb. So before there would have been 2 paths. If the current went through the bulb, there would have been 2 paths for the current to take. The black path and the purple path. Okay. But if the bulb is blown, and that means that there's only 1 path to take. So now your resistance is actually increased. So you've got a mark for saying that resistance increased, because there's only 1 path for the current to take, and you use your resistance in parallel formula to show that. Right. So you could also explain that the resistor would now effectively be connected in series if the bulb blows, whereas when you've got the bulb and the resistor, then they're connected in parallel. But if you remove the bulb, then the resistor is effectively now connected in series, because actually you don't need that part of the circuit. So now your resistor is connected in series. There's only 1 path for the current to take if the bulb is blown. Okay. So effective resistance would increase. There's only one path for current to take. And by using the relevant formula would then be your 1 over R parallel formula, where R1 could be your bulb, for example, and R2 could be your resistor. So there's the formula that you needed to have. Okay, that was question 3. Question 4. Teenage Mutant Ninja Turtles live underground in the sewers. They access the streets in the city above by lifting up the sewer covers. We also know them as manhole covers. Define weight. Again, straightforward definition from your notes. The force with which all objects with mass exert on each other, or you could have also said the downward pull of the earth on all objects. So the mass of the manhole cover is 0.04 tons. That you need to convert to kilograms because ton is not an SI unit. So calculate the weight. So formula for weight, Fg equals to mg. First convert that for 0.04 tons to kilograms by multiplying by 1,000. So you should have got 40 kilograms. I need to show that. So first of all, 0.04 tons equals to 0.04 times 1,000 kilograms, which is equal to 40 kilograms. Then you take that 40 kilograms. If you wanted to, it is acceptable to include this in place of that if you wish. You don't have to, but you can. 40,000 times gravity on Earth, which is 9.8 meters per second squared, and 40 times 9.8 is 392 newtons. Remember, 2 decimal places. You could have gone 3,92 times 10 to the 2 if you were using scientific notation. There we go, there's the weight. Draw a fully labelled free body diagram to show all the forces acting on the sewer cover lid while it's stationary. Stationary meaning still, so no net force. Whenever you've got something that's still, F net equals to 0 newtons. Resting on the ground as it's shown in the photograph on the right. So there we go, it's just on the ground. So every object with mass in the universe has weight, and weight acts vertically downwards. So we call that Fg, and Fg is the weight. Why is it not being pulled down into the ground or being like indenting into the tar? For example, like if you were to stand on quicksand or stand on water, you would sink. Because the surface isn't able to push back on you. And the reason why is because you've got the normal force, which is the reaction force of the surface pushing upwards on an object. So F subscript n, so F is for force, n is for normal, and then you must write that that is the normal force. There's the dot to represent the sewer cover lid. The length of your arrows, I didn't really get a ruler out and measure, but the length of this arrow, the up arrow, should be equal to the length of the down arrow. So please make them look approximately equal. If you have got lines on your page, then do it so that your dot is on a line, and maybe do it so that the length of the up arrow is 3 lines long, 1, 2, 3, and the length of the down arrow is 3 lines long, 1, 2, 3. So the length of the up arrow equals to the length of the down arrow because F net is 0 because the object is stationary. So it's resting on the ground, it's not sinking into the ground. The ground is pushing back up on the sewer lid. Some of you drew weird things, some of you tried to redraw this picture. No, that's not how you draw a free body diagram. That was just proof that you hadn't even done one single past paper and answered any of the questions in your notes. In your force, work, energy, power notes, you asked to do many free body diagrams. So again, should have got full marks for that question. That was straightforward from your notes. Raphael lifts up the sewer lid, which we now know to be 40 kilograms. He raises the lid by a height of 0.25 meters, then holds it stationary so it's not moving while he looks out for villains as in the picture below. Define work, that's a definition straight from your notes. Calculate the work done when he lifts the sewer cover lid 0.25 meters. Formula for work. Work is equal to force times distance. Okay, you calculated the force. This was the force of gravity that you calculated above over here. Fg is equal to 392,00 newtons. (392 times 0.25). You don't need to convert because meter is the SI unit for distance. If it was in centimeters or kilometers, then you would need to convert. But it's already as a SI unit, so no conversion necessary. So that means 392 times 0.25 gives us 98 joules. Remember, 2 decimal places. If you wrote it in scientific notation, 9.8 times 10 to the 1 joules. Okay. Raphael thinks he's going to do more work by holding the sewer cover up for 3 minutes. He thinks he does more work when he holds the sewer cover up for 3 minutes rather than half a minute. Is he correct? No. What is the formula for work? There you go. Work is force times distance. Do you see time in this equation? Is it first force times distance times time? No. And this was the same type of question that was in your controlled task for term 2. So the formula for work is equal to force times distance. Work does not depend on time. So even if you held the sewer cover lid up for a year, or for 1 second, or for 2 days, who cares how long he held it up for? Work depends on force, so the weight of the object, force due to gravity, force times distance. Okay. Did the force that he exerted on the object change to hold it up? No. Did the distance that he moved it change? No. Only the time changed, and time is not in this equation, so that's why. So no, he's not correct. The formula for work is work equals force times distance. It doesn't depend on time, so it's irrelevant how long he holds up the lid for. Only the mass or the weight of the lid and the distance which the lid move matter. Define power, that's from your notes. Calculate Raphael's power. So we need to know what power is. If it took him half a minute a minute is not a SI unit, so you need to convert half a minute divided by 1 minute is 60 seconds, so half a minute is 30 seconds. To raise the 0.04 tons, remember that was 40 kilograms. Sewer cover lid by, that is going to be our distance. Formula for power. Power equals to work divided by time. Some of you guys use this formula, which is for pressure, which you haven't done yet. Why would you use a formula that you haven't even seen before? That's term 3's work, guys. This is not power, this is pressure. And yes, it's in your formula sheet because that's the standard formula sheet that you're going to be given at the end of the year and next year. So please don't use that. That's pressure. Don't know why some of you felt the need to use a formula that you shouldn't have ever seen in your life before. Very weird. So power is work divided by time. The work done is from this question over here where you calculated the work done. So that 98 goes into there for your work. It's 98 joules divided by a time. I told you time is going to be 30 seconds because it's half a minute. So on the side you just go 1 minute is 60 seconds. Therefore half a minute equals to half or 0.5 times 60, which is then 30 seconds. You need to show this. So 98 divided by 30 seconds gives us 3,27 as the value. Now remember, power is measured in watts, capital W. Okay, so you've got a mark for converting. Formula, substitution and answer. Alright, last question for the winter assessment. The weapons of mass. We've got Raphael's known to be the strongest fighter in the group. Raphael's beaten his brothers, including Leonardo, before in fights. Both were done without weapons. They're having a debate. Each think that they expend more mechanical energy. And if you don't know what mechanical energy is, it's fine because it's explained over here. More mechanical energy to pick up their weapon from the floor. So if the weapon's on the floor, pick up their weapon, raise it to a height of 1.6 meters. So this height is 1.6 meters. So pick it up from the floor, lift it up to chest height, 1.6 meters above the ground, and then throw their weapon towards a wall, which is a distance of 10 meters away. So from here to there, actually I should lift that up. So from their chest height to the wall, that is 10 meters, and the height above the ground is 1.6 meters. So let's quickly run through that again. So here is the object. It's on the floor. They need to lift it up to a height of 1.6 meters. That's 1.6 meters. And then they throw it a distance of 10 meters to a wall. Okay? Mechanical energy is the sum. Sum means add. Kinetic and potential. So EM, mechanical energy, is potential energy plus kinetic energy. And that is mechanical energy. Leonardo is standing on Earth. Leonardo's weapon is a katana, so that's a katana. It's got a mass of 4 kilograms. He lifts it up to 1.6 meters above the ground, then he throws it horizontally at a velocity of 100 kilometers an hour. Remember that you need to convert to meters per second if you're going to do any calculations, because kilometers an hour is not an SI unit. Raphael's got a psi. So there's his psi. It's got a mass of 3 kilograms. Sorry, this isn't actually the last question. We've still got question 6. So his psi has a mass of 3 kilograms. And the total mechanical energy, so remember mechanical is equal to potential plus kinetic. So his total mechanical energy, when he picks up his psi from the ground, raises it to chest height, and then throws it horizontally, is 150 joules. So this is his mechanical energy. Raphael's mechanical energy is 150 joules. So a bit of reading was required there. Although the force of gravity is acting on each weapon, remember gravity acts vertically downwards. Gravity never pulls something forwards or backwards, only downwards. The weapons tend to continue moving forward horizontally until they hit a wall. Use the correct, specific terminology to explain why their weapons tend to continue moving in the same direction, meaning forwards horizontally. So in this case, they're moving to the left. Guys, this was a question on inertia. Again, very similar to the question in your controlled task. The weapons have got mass, and therefore they've got inertia, and therefore they will remain at rest or continue moving with constant velocity. So they had inertia, and that's why they would continue moving or remain at rest. So inertia is the property of an object. And that was the specific terminology, was what I was wanting, was inertia. Okay, define energy, that's straight from your notes. Calculate the increase in potential energy of Leonardo's katana and Raphael's psi separately. So that means, like, so just take your page. There's your page. If this is question 522, 5.2.2, split it in half and do Leonardo and Raphael and do your calculation. Formula, substitution, answer. Formula, substitution, answer. So that is done in the memo. Raphael's potential energy came to be 47,04. So for potential energy, it's mass times gravity times height. Leonardo's, actually let's do Leo quickly. EP equals mass times gravity times height. The mass of his psi is 4 kilograms. Gravity on Earth is 9.8 meters per second squared. Chest height is 1.6 meters. So he lifted it up to a height of 1.6 meters. Because he's lifting it up above the ground, from the ground up, it's gaining potential energy. Multiply all those together and you get 62.72 joules. And please label your work so that this is Leonardo's potential energy. Then we're going to do Raphael's. I don't have space to do it side by side, so I'm going to do Raphael above Leonardo. So there's Raphael. Again, you write down the formula again. Mass times gravity times height. His weapon was 3 kilograms. I think I called Leo's weapon a psi, and I was wrong there. Leo had the katana. Raphael had the psi. He's got a psi. This is a katana. Doesn't matter though. So mass times gravity times height. The mass of Raphael's weapon was 3. Gravity on Earth is always 9.8 meters per second squared. Chest height is still 1.6 meters. You don't need to actually write that meter. You can if you want to though. Okay, and that would give us 47.04 joules of potential energy. So that's the potential energy for Raphael. Please, like I said, make sure you label it that Raphael is maybe on the left, or like here I've labeled Raphael and Leonardo. Please do that so that I know what it is that you're calculating. Okay, so we've calculated the potential energy increase for each of them once they've been lifted up. Now we're going to calculate the kinetic energy of Leonardo's katana as it moves through the air. So formula for kinetic energy, EK equals half mv squared. You were given that. Before you do that though, so you need to have half times mass times velocity squared. So half is going to be 0.5. The mass of Leonardo's weapon was 4 kilograms. And velocity was the 100 kilometers. Was it 100? Yes, 100 kilometers per hour. You need to convert that to meters per second. So 100 kilometers per hour. To do that, you need to divide by 3.6. And that will give you 27.78 meters per second. You have to show this calculation in order to get your mark for your conversion. Okay, so the velocity is going to be 27.78, and so many of you forget to square it. You write down the square in your formula, but then when you substitute you don't square it. Very weird. And that gives us that the kinetic energy of his psi while it's moving through the air, where's that little diagram that I did before? So there we go, while it's moving horizontally, so not the vertical part but this part, the horizontal part. It's moving that way from right to left at 100 kilometers an hour, or 27.78 meters per second. So its kinetic energy, its moving energy, is 1543.46. Energy is measured in joules. If you do it in scientific notation, that's fine. 1.54 times 10 to the 3 joules. Okay, you lost a mark if you didn't convert. Who threw their weapon with the greatest velocity? Justify your answer with a calculation. Oh, I've missed something, sorry. Okay, so that was the kinetic energy of Leonardo's katana. Now I need to do question 5.2.4. Using the total mechanical energy, remember mechanical energy is potential plus kinetic. And you were told that that was 150 joules. There you go, there's Raphael's mechanical energy, 150 joules. And that was for Raphael. Okay, so using the total mechanical energy for Raphael's psi, so that was 150 joules, calculate how much kinetic energy Raphael's psi must have had as it moves through the air. So we've got mechanical energy equals EP plus EK. You were told that the mechanical energy was 150 joules. The potential energy you calculated in question 5.2.2. The potential energy for Raphael was 47.04 joules. So Raphael's potential energy was 47.04. And the kinetic energy is what we're trying to find. Take that to the other side, take the 47.04 to the other side, so 150 minus 47.04 will give us a kinetic energy of 102.96 joules. You can write it in scientific notation, 1.03 times 10 to the 2 joules. So there we go. Only 2 marks. Who threw their weapon with the greatest velocity? So you had to work out the velocity. Now this was quite an advanced question. So for Raphael, his kinetic energy is equal to half times mass times velocity squared. The mass of Raphael's weapon, the psi, was 3 kilograms, and the velocity squared is what we're trying to get. His kinetic energy was 102.96. That's what we calculated over here. So we're going to take that value and put it over here as his kinetic. Okay. So 102.96 divided by a half times 3. Will give you V squared. Okay. So V squared, I'm going to carry on over here. V squared is actually going to be 102.96 divided by 5, which is 68.64. Now, if you need to solve this, you need to square root this side and square root that side. So now the square cancels out the square root. So the V squared gets cancelled out by the square root. So that means that you're going to be left with just V. This is why you need science, you need maths to do science. So V is equal to the square root of 68.64, 8.29 meters per second. Okay, and that was for Raphael. So Raphael's velocity, the velocity that he threw his psi, his 3 kilogram psi, was 8.29 meters per second, whereas Leonardo was 27.78. So now the last question asks, who had the greater mechanical energy? So mechanical energy, remember, is both. So this was his velocity. Leonardo's mechanical energy, you'd have to add 62.72, which was his potential. So there's Leonardo's potential, 62.72. Let's do Leonardo in blue. Okay, so his potential was 62.72. His kinetic, we calculated over here, 1.1543.46. So over there, 1543.46, and that would give us 1606. Okay, so that was for Leonardo. Let's work out Raphael's. Raphael's, they told us, was 150. There we go. His is 150 joules of mechanical energy. Okay, so Leonardo's 1606.18, Raphael just 150, so obviously Leonardo's mechanical energy was much greater. You didn't have to show the calculation, you just had to say Leonardo. But if you didn't realize that this, the 1500 and the 60 odd, was much greater than that, then this is how you do it. So Leonardo's was greater. Last question. We already know that Michelangelo loves pizza. Michelangelo suffers from low blood levels of phosphorus. Tripotassium, now remember tri means 3. Tripotassium phosphate, so potassium, tripotassium is K3, and PO4 is the formula for phosphate. You didn't need to know that, which is why I gave it to you. So tripotassium phosphate is used to treat the low blood levels of phosphorus. So if he's got low blood phosphorus, he sprinkles some tripotassium phosphate powder onto his pizza so that he can increase his phosphorus. One day Michelangelo's making his own pizza. They need help. They leave in a hurry that he forgets about the pizza that's still in the oven. Define compound straight from your notes. Classify K3PO4 as either a compound or a mixture. So a compound is a substance that's formed when two or more different elements are chemically bonded together. Here we've got one element, potassium, another element, phosphorus, another element, oxygen. So we've actually got 3 different elements that are chemically bonded together. Okay, so because of that, 3 different elements chemically bonded means it's a compound. So it's a compound because it's got 3 different elements chemically bonded together. How many atoms are present in K3PO4? So if you've got K, you actually need to have 3 of them. K3 and then phosphorus. There's 4 oxygens on it. O, 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 O. So there you go, there's your 3 potassiums, 4 oxygens, and 1 phosphorus. So I've got 1, 2, 3, 4, 5, 6, 7, 8. 8 atoms bonded together. There are 8 atoms bonded together. Name the group in which you find potassium. Yeah, it's group 1, the alkali metals. Alkali metals. Identify each element, so the potassium, the phosphorus, and the oxygen, in tripotassium phosphate as either a metal or a non-metal. Potassium is a metal, especially if it's found in the alkali metals, because it's to the left of the step line on the periodic table. So group 1 is obviously far to the left on the periodic table, so potassium is a metal. Phosphorus and oxygen, non-metal. Write a specific word equation for the chemical reaction which would take place if pure potassium were to be burned in oxygen. Specific means not a general, so you don't go metal plus oxygen. Actually need the specific equation, and I said a word equation, so don't give me chemical symbols in a word equation. So you've got potassium, so you write potassium plus oxygen. Now the general equation that's in your notes is a metal plus oxygen reacts to form a metal oxide. In this case, the metal that we've got is potassium, burning in oxygen. To form the metal oxide that we're going to get now is going to be potassium oxide. Okay. Tripotassium phosphate reacts with barium fluoride according to the following chemical equation. Just by the way, I want to show you that this chemical equation was straight from your notes. It's actually on page 16 of your notes. Have a look at that. So if you struggled with this question, just proof that you didn't even look at your notes. Alright, so here you have to write the UPAC name for BAF2. It's barium fluoride. Not barium fluorine, barium fluoride. Write the UPAC name for KF, that would then be potassium fluoride. Rewrite the word equation as a balanced chemical equation. So again, go rewatch the video from last term on balancing chemical equations if you couldn't balance it. And that was the same as the one that was in your notes, which I've just shown you. So you don't need to write any number here. It's just going to be a 1, so you can leave it blank if you want to, but if you wish, you can write a 1. So 3, 2, 1, 6 for the balancing numbers for that. I've got nitrous oxide and nitrogen dioxide. N2O for nitrous oxide and NO2 for nitrogen dioxide. Ask Michelangelo says that N2O and NO2 are exactly the same compound with the same properties because they have the same elements and number of atoms. Raphael says that they are not the same. Who do you agree with? I hope you all agree with Raphael because Raphael is correct. Alright. Explain fully. So although N2O and NO2 both contain nitrogen and oxygen. So yeah, sure. Here we've got nitrogen and oxygen and oxygen. That's wonderful. But for nitrous oxide, we've got N2O, whereas for nitrogen dioxide, you've only got N1O2. So we say that the the subscripts are different. And if the subscripts are different, they're not the same compound. So here we've got N2O, 1, N1O2. Remember, if there is no number, it's a 1. There's an invisible 1 there. You have been taught that. So, yes, they've got the same elements, but because they're combined in a different ratio, they are different compounds. And if they're different compounds, they've got different chemical and physical properties. So they're not the same. So Raphael's correct. Although N2O and NO2 both contain the elements nitrogen and oxygen, N and O, the N2O ratio, the nitrogen is to oxygen ratio, is different because the subscripts are different, meaning these little blue numbers that I've written here, 2, 1, 1, 2, those are different. So here you've got 2 is to 1 for your N is to O ratio, whereas here you've got for your N is to O ratio, you've got 1 is to 2. So they're different ratios. And that's why they're different compounds. They've got different formulas, and they've got different properties. Okay, I hope that helped you guys. Please make sure you do lots of past papers. You've seen how valuable they are. And ask your teacher if you've got any questions about any of the past papers or any questions in this winter assessment. Thanks, everybody. Bye.